All right, friends, it's T-Man. Guess who we're back with? Our favorite YouTuber. One of our favorites, bro. I am Longevity, besides Jason Blaha. I am Longevity, the motor unit longevity slave, broski. So we're going to react to his new video he just posted. I just saw it on the feed, so I figured, hey, man, I got to do a reaction to it. So, Tony from I Am Longevity says, what dies first when you age? It's not muscle or motor units. Wow, man. Okay. I'll get into this in a bit about motor units. Just the same as muscle. Let's just put it this way. I'll tell you right now. Like I say in my videos, muscles post-mitotic. Well, guess what? Motor units are post-mitotic as well. All right.
Hello everyone, welcome back to the channel. December 21st, 2025. It has been a while because I was making this video. It's about an hour long.
Wait, just before we start, what makes you think, okay, hold on a second. Yeah, what dies first when you age? It's not muscle, it's motor units. Okay. Man. Bro. Okay, so look, motor units are post-mitotic. So I cannot tell you how many motor units you were born with as opposed to another person. I'll try to clarify this. So everybody is born with a certain amount of muscle fiber count. You have a muscle fiber count. Now, some people may have more muscle fiber counts than you. Unfortunately, I'm sorry. That's just genetics, okay? That is genetics. All right. So there are individuals that are out there that have possibly more motor units than you. You understand me? So yeah. Now, as far as recruiting motor units, everybody can recruit a motor unit. But as far as having more motor units than another individual, well, sorry, you cannot change that, unfortunately. All right? But you can recruit them. So if you're trying to compete with somebody that has more motor units than you and stronger than you, then yeah, go to a gym, try to recruit more of these motor units, branch them, whatever, bro, get it? Just whatever. It's just like the muscle fiber count. You see some people, they're big, brutishly strong, whatever. They have more muscle fiber count than other people. So what do? They want to compensate. They go to gyms, whatever, try to compensate for that. Then they say, look, I'm stronger than you. Okay.
I will leave timestamps below in case you don't want to watch the whole video. So let's get into it. For decades, we've been told that as we age, we permanently lose our motor units.
As we age? Yeah, age is a measure of time. You mean as we deteriorate? Well, you could stop the deterioration and make sure that your body is in a regenerative mode instead of deteriorating it. And you, like, how should I put it? You feeding this degeneration by instigating it, by feeding it, get it? With your peasant slave food diets and crazy exercises and shit. That's all your body needs is, wow, it's not enough that we need to, regenerate ourselves constantly. But now we have to deal with his bullshit. Your crazy habits and shit.
Once they're gone forever. But some scientists have made very bold claims. They're saying that the loss of motor units can actually be reversed. If you remove a specific factor,
the loss of motor units could be regained. Well, let's see. Hold on. We do know that they're post-mitotic. How do you build muscles are post-mitotic? Hold on a second. Shit. Man. Fuck it, man. Here's a statement. This is just a statement, okay, dude? So this is a section, overview, whatever. Yes, the statement is accurate. The motor neuron component of motor units is post-mitotic, meaning these nerve cells do not divide and once lost cannot be replaced. Now, I don't know about them being lost. Can you lose an entire fiber, like a fiber? Yeah, you can lose it, but will it add any significance that you lost a couple of fibers, man? Like, is it going to make a big difference? Holy shit, man. I have 150,000 fiber count, but I lost 3. Will it make a huge difference? Not really. See what I mean? Unless you lost a significant amount of them. I don't know. Now, will it make a big difference because, oh, man, fuck, I lost some of these fucking motor units, bro. Get it? Holy shit, man. But guess what? They can branch. You can activate them. They can branch, bro. Get it? from existing ones. They compensate. Everything in your body in science, what they found out, compensates. That's why they do these crazy tests. They go, look, we took away the satellite cell, but guess what? The body compensated by doing this instead. It used some other progenitor cell to cause some myogenesis or whatever, blah, blah, blah. So, yeah, bro, it's not going to significantly do much to you. But maybe psychologically, in the crazy brain, it might affect you because people here are all sick on the peasant slave food estrogenic diets, all these men. They just can't stop eating the estrogenic diet. So they think they're weak in the head or some shit. Anyways, a motor unit consists of a single motor neuron and all the muscle fibers it innervates. It innervates these muscle fibers. So either way, if you lose muscle fibers, will it innervate those muscle fibers anymore? Fucking no. So one way or another, you're going to win or lose. So if you lose fibers, if you actually lose a fiber, right? Guess what? There's nothing there to inner-fucking-vate. Get it, dude? See what I mean? Now guess what? If you have muscle fibers, they can branch because these motor units, they can proliferate. They can branch, okay? So whatever. Anyway, yeah, you can recruit motor units. Lifting. Motor neurons. These are highly specialized cells that permanently withdraw from the cell cycle during development. They are amitotic and cannot undergo mitosis in adulthood. When a motor neuron is lost due to an injury or disease, its function cannot be restored through cell division. Muscle fibers, no, they can't be, but it can branch through recruitment of motor unit. They compensate. The other motor units will compensate by branching. So, muscle fibers. The myonuclei within skeletal muscle fibers are also generally considered postmitotic. Yeah, the myonuclei are postmitotic. They do not split and divide. So you have to get the satellite cell to donate its nuclei. That's the one thing that we have that we can actually do is actually by causing micro damages, we can activate that by causing it. We have to cause the micro damage. And a micro damage environment happens where? Extreme, unaccustomed, unfamiliar, and untrained muscles in eccentric exercise is able to activate the progenitor cell. Those are the key factors to activate it, to get it to donate its nuclei, to support further growth of that domain. Anyways, however, the muscle tissue itself has a regenerative capacity through a population of stem cells, called satellite cells, which can proliferate and aid in the repair growth through the original nerve connection. The original nerve connection cannot be rebuilt. The permanent nature of motor neurons is why damage to them as a motor neuron disease can result in lasting weakness, atrophy, and loss of muscle function. Yeah, it could happen. It's unfortunate, man. So don't get a disease or anything, because if you do, even if you cure the disease or whatever, you've got a loss of these so-called motor units. But I wouldn't worry. You can still branch them by lifting. You understand me? So yeah. But whatever it is you're doing, they'll branch, okay? They'll compensate. Let's just put it that way, whatever. Let's go back to the video.
Or intervene in a specific way, motor units can in fact come back.
They cannot come back. They cannot come back. They can branch. You can branch them. We've talked about this before.
Aging, at least at this level, may not be permanent after all. So the question is simple.
He's wasting his time exercising. I told all you people, you're crazy. You're wasting your time I'm going to maintain muscle through exercise, or I'm going to build muscle, or I'm going to maintain these motor units through exercise, or I'm going to exercise and I'm going to get more motor units. You're not going to get more motor units. They're post-fucking-mitotic. You can branch them. You can get them to branch by activating them. That's about all you can do, dude. Get it? You get it, man? Just like muscles, they can only hypertrophy through some fake means or some damage means, like something specific.
Is this actually true? Today, we're going to carefully walk through the science behind these claims.
The science.
Not headlines, no interpretations, the actual studies. And along the way, I'm going to show you something in this video that has never been put together the way I put it together. including critical flaws and
Oh yeah, the
details that
way he puts it together.
even the scientists themselves don't fully address.
Sure they don't.
Can the loss of motor units actually be reversed? Sit down and get your popcorn because this video is not like any other on the subject ever seen.
No, they can't because they're post-mitotic. Get it, dude? They're post-mitotic. See what I mean? Yeah, it's crazy. I know what he's talking about.
Let's get into it. Let's go back to 2019. A neurologist named Aaron Bookman, MD, published a study that almost nobody paid attention to. But if you understand what he found, it should have changed the entire field of aging, but it did not. Here's what he did.
What does it have to do with aging, man? Aging is a regenerative thing. It's based on regeneration. You have to outpace the degeneration by regenerating faster. You have to regenerate faster than you are degenerating. So muscles are proteins are being built up and broken down, right? Okay. Can you outpace the degeneration that's coming in? Hold on a second. So you have natural degeneration. Let's say if you're on your natural diet, okay, like a cow eating grass. So what do you have to worry about? Oxidation. There's oxidation. There's a bunch of things that are going to come into your body. Your body's going to go through some regeneration, whatever. It's going to clean up the shit, whatever. So it's removing bad proteins. You're adding new proteins, but you are eating the wrong food. Get it? These so-called proteins and things are affected by it. So you're building up bad protein still, and bad's coming out, coming in, coming out, whatever. So you're not outpacing this degeneration by regenerating. The regenerating is not outpacing the degeneration. That's why when you look in the mirror, you see a mummy looking back at you. You don't see a normal human being the way you should be looking. Here's the thing. You don't have anything to go off of because you look around and you see everybody else looking the same. So in your head, you think, well, they're all degenerated, so I just might as well continue in the same behavior like them because guess what? I'm just going to look like them anyways. No, you're not. No, you're not. You're just imagining things. That's like saying, well, I should look like everybody else, all these slaves that have short hair, and I should cut my hair short like them because everybody should have short hair, all slaves. Get it, dude? Not everybody should have short hair. Not everybody's a slave that has short hair. You know what I mean? Like, or whatever. So, yeah, you can have long hair. You know what I mean? But they're going to associate things with long hair to try to disassociate things with long hair as being bad. The opposite of what is masculinity. And the truth is, short hair is demasculinizing. So it's kind of like whatever, feminizing. It's actually the opposite.
A group of very old people. These were people in their final years of life. He tracked their motor function while they were alive. How fast they walked, how steady they were, how strong they felt, and how their legs responded.
Sure.
Then something rare happened. After these people passed away, they donated their spinal cords for research.
Great.
So now Bookman could do something no other study has done before. He could compare how a person moved to what their actual motor neurons look like after death. And here's what he found. The men, but not the women, who moved better have more motor neurons. The people who moved worse had fewer. And the ones who had the worst movement,
they had fewer, they had more because they moved worse? That doesn't make any sense. You mean they were branched because they were doing something, working, or whatever they were doing? You mean they were activated? You don't have more or less of them. You have the same amount of motor units that you were born with. They're post-mitotic. Now, if you were, like they said, if you had a disease or something, it's a possibility you could lose them, just like you could lose a muscle fiber. It's a known fact. You can literally lose a muscle fiber, right? But is it significant enough to notice? Like, would you notice? And again, the body will compensate. The body compensates for everything.
their spinal cords had the highest level of activated microglia. That's the brain's immune cells that become aggressive in old age. Much more on microglia later in the video, so please remember the word. In his own words, he concluded, activated microglia in the spinal cord may contribute to motor neuron loss in older adults. He assumed that microglia were strongly connected to the way people slow down as they age, but he never went into detail as to why the microglia seemed to be involved. And that is where the next study comes in. Now, let's jump to 2023 because this is where things finally start to make sense. In 2023, Ryan Castro and his team released a study that went much deeper than anything before. He wasn't just counting motor neurons like Bookman, he wanted to know why these neurons stop working as we age. So he looked at mice, monkeys, and humans, including people in their 20s and people in their mid-70s.
I don't know. Maybe it's an electrical charge. Maybe that's why they stopped working. Who knows? I don't even know what he's talking about. How do they stop working exactly? You're dead. Why would they keep working if you're dead?
This is the first study that examined motor neurons in mice, monkeys, and humans at the cellular and molecular level, meaning they finally looked inside the motor neurons, not just on the outside. They showed that motor neurons do not die or change as we age. They always remain as they are in number and in size.
Yeah, they remain in number and size. Why? Because they're post-mitotic. Duh.
Remain as they are in number and in size. So,
like I said, because they're post-mitotic. That's why.
Why weren't they firing? Why weren't they responding? Because the signals from the brain stopped getting to them. They then proceeded to find out why the signals weren't reaching the motor neuron. So what did they do? They went backwards, tracing the pathway up. He was looking for the exact spot where the signal was being blocked. Step by step, level by level, they followed the wiring until they reached the real problem, a tiny area in the ventral horn called the excitatory synapse. Remember the ventral horn and the excitatory synapse because more on this later. The excitatory synapse is the gas pedal connection. That's the part that makes you move fast. And in all the human spinal cord they examined, this connection was gone, erased, pruned. And right next to it, they found another connection called the inhibitory synapse.
Well, then I should be dead already because it's gone and my spine is completely gone, man.
That's the brake pedal to stop you. These are the ones used to slow you down.
Well, that's a brake pedal, okay.
They were still intact. As for the excitatory synapses,
they were still intact, yes, okay.
There are two different types. VGLUT1, which stands for vesicular glutamate transporter 1, and VGLUT2, vesicular glutamate transporter 2. Each serves a different purpose, which I will break down thoroughly later in the video. And this is the part where his 2023 study becomes somewhat puzzling. In the mouse experiments, Castro clearly showed that both types of excitatory synapses, VGLUT1 and VGLUT2, were lost with age.
You want to know why they stopped working? Because you're deteriorating faster than you can regenerate. The only thing that can regenerate you are progenitor cells in your body, the stem cells that you have. See what I mean? Now, you don't want to be a chronic exerciser because you will expose them to a nasty environment and then you'll lose them. You get something called myogenic decline. With every myogenic decline, guess what? You have lesser and lesser abilities to outpace the deterioration in your body. So you want to keep a reserve in the stem cell pool. So your exercise should be geared towards regeneration and not degeneration. But people go to the gym and they think they're regenerating or whatever it is they're doing. They're actually degenerating. They're actually accelerated. That's why we say accelerated aging. Accelerated aging is just a word for you are not outpacing the degeneration. You're not regenerating faster than you're degenerating. You're degenerating faster than you can regenerate. See what I mean? So your exercise truly should be geared towards regeneration so you can outpace degeneration. Get it? So that when the satellite cells do leave quiescence, you don't want to expose them to a nasty environment. So you must eat your natural food. Number one, you got to eat raw natural food. That's a given. If you expose them to peasant slave food, estrogenic drug addict diet, then guess what? they're gonna be destroyed. All right, they're fucked too. The progenitor cell, and then they go back into quiescence. They go back as a sickly whatever, a sick progenitor cell back into quiescence, which is a bad thing. That's why they're in quiescence. They're in quiescence to protect themselves from this degenerative environment, but they are only active when it's time for them to regenerate you. Possibly when you're asleep, they call that autophagy. So they may come out in sleep because, oxidative damage, blah, blah, blah. They come out, they kind of regenerate you when you're sleeping, and then they go back into quiescence. So is there more than one way to activate these progenitor cells? Yeah, of course. It doesn't have to necessarily be in the gym. They will come out at night and regenerate you. But if they come out in a very nasty, toxic environment, alcoholic, drug addict, drug induced, this, that, peasant slave food diet, man, it's going to give them a hard time, bro. You're just making them just exhaust. You're exhausting. Here's the thing. You are exhausting the stem cell pool. We don't want to exhaust it. We want to expand it. So don't go to the gym exhausting it. Go to the gym with the idea of expanding this pool. Get it? So you have for further regenerative demands. Get it? You understand me? And eat a natural diet. That would definitely help.
But did not measure or report VGLUT2 in primates or humans. Since the human and primate data only shows VGLUT1 findings, it is unclear whether VGLUT2 in old age has decreased so much that it becomes undetectable. It looks like that the loss must occur much earlier in life. I will explain later in the video why VGLUT2 is extremely important and why it coincides with type 2X motor units. So now that you know the motor neurons are still there and the problem sits above them, we have to zoom in on the exact spot where everything goes wrong, the ventral horn I mentioned earlier. At every level of your spine, neck, mid-back, and lower back, you have two ventral horns, one on the left, one on the right. There are 31 ventral horns on each side of the spine, totaling 62 in all. Inside each of these ventral horns live your lower motor neurons. These are the motor neurons I've been talking about for a long time. They send the final command to their axons. Think of these like electrical wires carrying the signal directly to your muscle fibers, telling them to contract. So, how do the signals get to the motor neurons? The brain's upper motor neurons send a fast go signal down the cortical spinal tract. That's a scientific word meaning brain to spine tract, into its respective ventral horn, where it lands on the motor neuron. That motor neuron that fires and sends the command out to the muscle. But again, the question is, how does that fast go signal reach the lower motor neuron from the ventral horn? This is where the excitatory synapse comes in. Yes, the very ones Castro and his team found missing in older people. Think of it like a microscopic bridge inside the ventral horn. The relay point where your brain's fast move now signal.
What about all of this?
Crosses into the lower motor neuron.
Yeah.
This is the connection responsible for every explosive movement you can produce. What carries the fast signal across this bridge? The signal or input is carried by a neurotransmitter called...
Man, he just thinks it's about the fucking motor unit. It's also about your fast twitch muscle fibers and things, because that's where they reside. Can you see this so-called motor neuron? I don't know. I don't know what these scientists are talking about. How do you see a motor neuron? Can you literally see it? Like, what does it look like? You know what I mean? It's crazy.
Glutamate. Glutamate is the chemical...
A neurotransmitter. Have you seen what a neurotransmitter looks like? I think it's like phenylalanine. Is it phenylalanine, this amino acid? Isn't that what shoots off these neurotransmitters? I knew people trying to take phenylalanine and lifting. They would take it as a single amino acid. You could buy them in these stores. So they would take them and lift weights because, well, it was used in the brain. It would shoot off these neurotransmitters, right? So they thought that this would help with the motor unit and lifting something heavy, bullshit, whatever. I don't know. They had these crazy ideas. People had crazy ideas, dude.
Go message. It's the green light. It's the accelerator. But glutamate doesn't cross this bridge by itself. It travels inside tiny vehicles. and they are VGLUT1 and VGLUT2. These vehicles are like Lamborghini.
Yeah, sure they are. VGL21 and VGL2, they're like Lamborghinis. Yes, they just travel back and forth. Yes, you could see them every day looking at it. Yes, just take a look. You see them there traveling, man.
Delivery vehicles. They carry the brain's fast command across the excitatory synapse.
Okay.
Let me briefly explain the difference between.
Look, man, I'm not a doctor or a dentist or a lawyer or any of these fucking things or a scientist, dude. I don't know what I'm talking about. Don't listen to me. This is just for entertainment purposes only, okay? This is just comedy hour, bro. And that's it, basically. So, yeah, I'm just giving some opinions and facts and some stuff, whatever. But I don't know what I'm talking about, so don't listen to me.
VGLUT1 and VGLUT2, because this is where everything starts to make sense.
Okay.
When you're about to deliver one single burst of power, a max jump, a punch, a one rep sprint step,
Yeah, sure.
your body uses VGLUT2.
Oh, it
That's
does,
the
does it?
pure one shot explosive
Oh, it
command.
does it? And you know this how? Because they wrote it on a piece of paper. They told me, okay. You know what I mean? You see what I mean? Here's the thing. I say post-metodic, but it's an observation. It's observatory. In other words, you see people doing stuff and you see people atrophying, hypertrophying, atrophying. But even when people atrophy, whatever it is that they're doing, they hypertrophy, they always go back to something called homeostasis. So you notice that muscles are post-metodic. Why? Because they just don't grow. I've never seen anybody walking with a bull and their muscles magically grew. I didn't see anybody in the gym lifting weights and their mature muscles actually grew. They with every lift they go to the gym. Can you imagine with every lift the muscles would grow? That would be insane. That would be insane. Every job that you did, you went to work and your muscles would grow moving boxes. You'd quit because you'd never stop growing. You couldn't stop. You couldn't work anymore. Could you imagine if human beings were just made to hunt, and you could twist and throw a spear? You understand me? That's all you could do is throw a spear and kill an animal. Because if you were to move some boxes or move something, a weight or something, whatever, your muscles would keep growing. So that would prevent you from doing what? From doing any work. You know, could you imagine if it prevented you from doing any work, then you wouldn't be able to enslave anybody because they would just keep getting bigger, 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 and they become useless. That's why muscles are post-metodic, just like motor neurons. It's an observation. You're observing in the real world how things are working. People have like fucking spinal cord injuries and things. Look at them. They cannot move their legs. There's a whole bunch of factors that go into it.
Straight from the brain. This is your type 2X at work. Take a look at this excerpt on the screen. While VGLUT2 synapse exhibit a higher probability of release, transmit signals with a greater fidelity and shows
But who cares? What does this have to do with anything?
synaptic depression. Now, what does that mean? I broke it down. High probability of release, meaning they fire a big signal instantly. Greater fidelity transmission, meaning perfect for one-shot explosive commands. And the last one is show synaptic depression, meaning they do not like repetition. Your body uses VGLUT2 in other pathways, such as pain communication. However, do not confuse this with what I'm talking about here.
But here's the thing. What can you do about any of this? Nothing. So what is this video for exactly? What's it about?
Now, VGLUT1 is your repetition engine.
Yeah?
It's the pathway that keeps explosive movement running smoothly when you have to fire fast over and over again. Such
Sure, yeah.
as like jump rope, a fast combination of punches. VGLUT1 is used.
VGT. Go tell the kids in the schoolyard all these things. They don't give a shit, bro. Get it? They don't care about any of this, man. They're going to do whatever they want to do. That's all. They're just going to do whatever they want. Here's the thing. As young people, you can't tell young people anything. They're going to do it anyways. They're going to do whatever it is they're going to do. You're going to tell them, oh, this is, it's going to affect you when you get old. Don't do any of this. They're not going to listen to you. I never listened to anybody. I was young. And I would never listen to an old guy like this, a scarecrow. The scarecrow trying to, or whatever, or anybody telling me these crazy things. You know what I mean? I will do what I wanted to do. And kids will do what they want to do. And they have a very short attention span, children. Children have a short attention span. I know because I deal here. There's a school here, and there's a playground and a whatever, and a park. And so they come up to me. They used to talk. They used to talk to me before COVID. They would ask me some questions. I would make some videos in the park. They would come and talk to me, whatever. Yeah, their attention spans are very short. They'll do whatever they feel is best for them. They do what's best for them, and they love to play. Children love to play because they have lots of energy. They're young, they're fresh. They haven't taken on a lot of DNA damage from the peasant slave food diet yet. It's a slow progression over time. You're slowly deteriorating over time. But before you know it, it creeps up on you. And then you're like, holy shit, man, what am I going to do about this? And then you're like spending the rest of the next 2 decades to try to reverse it. You know what I mean? Instead of trying to stay static, now you're working on reversing it on top of it. Oh shit, that's a lot of work, bro.
Type 2A.
Now, that's why you want to stay static. You don't want to indulge in these artificial peasant slave food diets. So now with the internet and everything, people are learning. I mean, I think you should educate yourself and really get as far away as you can from peasant slave food diets and at least try and eat as much as you can your natural diet. And therefore, you won't have to compensate for all these things that people are doing now when they get older, like this guy coping about, I gotta do all these crazy exercise for motor units because I need to live to 200 or some shit.
Papers at work.
Stop wincing at your bank statement after all.
Take a look at the excerpt above for VGLUT1. VGLUT1 synapses exhibit a lower initial probability of release, are associated with larger amplitude postsynaptic potentials, and show synaptic facilitation. Now let me show you what these mean. VGLUT1 synapses have a lower initial probability of release. It means they don't dump neurotransmitter all at once.
Okay.
The next one, they create larger postsynaptic responses. It means they build force and precision as they go. And then you have the last one here. They show synaptic facilitation, meaning they get better with repetition. VGLUT1 also...
They get better with repetition? How do they get better with repetition?
Powers your proprioceptive system. That's your internal GPS. Your proprioceptive signal actually splits in two. One copy makes
my proprioceptive... What am I proprio who?
an instant U-turn inside your spinal cord to fix your movement on the spot. And the other copy goes onto your brain so you know where your body is and can plan the next move. Take a look at the excerpt on the screen. It says afferents. I will talk about afferents later. From muscle spindle endings project to the spinal cord where they have extensive reflex connections, and also up the spinal cord to the cerebellum and brain where they are involved in programming and updating the command for movement and in a conscious appreciation of where the limb is in space. So let me explain some of these words. Afferents from muscle spindle endings project to the spinal cord, meaning the signal goes straight into the spinal cord first. It starts from the muscle. Then the other one is...
it starts from the muscle, goes straight into the spinal cord first,
have extensive reflex connections, meaning this is the fast automatic reflex loop that reacts instantly. The next words, also up the spinal cord.
It does it?
To the cerebellum and brain, meaning the same signal also travels upward so the brain knows what your body is doing. And finally, where they are involved in programming and...
Doesn't he look like that guy? Ha cha 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 cha. You just see the nose and the eyes behind the walls. You know what I mean?
Updating the command for movement. What this means is your brain uses this information to plan and adjust how you move. Cutting, spinning, redirecting, reacting without thinking. That's VGLUT1. I'm going to break this down in full detail later.
That's VGL1, guys.
Video, but for now,
he's going to break it down. Scientist Tony from I Am Longevity is going to break it down for all of us.
Just please understand this. This one small difference becomes the entire foundation of why we lose youthfulness. Now, what happens?
I would love to know, why do we lose youthfulness? Guys, why do you think we lose youthfulness? What do you think? What's the interpretation in your head? Like, think about it logically, intelligently. Why do you think loses this so-called youthfulness? What makes you lose it?
If VGLUT1 and VGLUT2 do not make...
I know, please don't say the word age. All right. Don't just say it's because we're aging. It's a natural process. Yeah, aging, you aging, going through time traveling is a natural process. But you deteriorating faster than you're regenerating is not a natural process.
To the muscle.
It's unnatural. That's why animals, they regenerate faster than they deteriorate. So they have children up to the day they die practically. They don't even know. They don't even know that. They know that they're going to die on the day they're dying, but they don't know when they're going to die, and they don't have any preconceived notion that they might get a disease and die, or their teeth will fall out and die, or some weird idea, some crazy thing like humans. Or fall down, break a hip and die, or some shit.
If they fall off that bridge for any reason, there is no fast signal. There is no message reaching the motor unit. And if there is no message, there will never be no muscle contraction. The motor unit goes silent, not dead. It simply has no gas pedal anymore. The bridge that carries the fast signal has been removed. And this is why, even though the motor neuron is still alive and intact, your explosiveness disappears first with age. The problem isn't the motor unit. The problem is the missing excitatory synapse, but it goes much deeper than this. So please stay tuned. Not that you understand.
Yes, I'm staying tuned.
The excitatory synapse.
I'm excited.
We have to talk about the
I'm excited.
opposite, the inhibitory synapse, or as I call it, the brake pedal. And remember what Cashel showed us. With age, we lose the excitatory synapses, but the inhibitory ones are.
With age, we lose it? So age has magic powers to make you lose these synaptics. Oh, okay. I had no clue. I didn't know that traveling through time has this power to make you lose synapse. So it's nothing to do with you deteriorating faster than you can regenerate. Okay.
Maintained, and in some cases they even increase. This is where things become.
Oh, they're maintained and they can even increase. Okay. Well, what does that have to do with motor units? They're post-mitotic.
Dangerous. What exactly is this inhibitory?
Look, man, he says that you're maintaining your motor units from losing them. You have to do all these crazy exercises, jumping in the park, flying up and down and everything. You got to maintain these fucking motor units, bro, because you're going to fucking go, man. Well, there's these people that live to 117, 120, and 30 years old fucking said it. These centenarians, bro, get it. They didn't fucking do any exercise. I don't know what Tony is talking about. Fucking motor units and muscles are post-mitotic. That's all. They don't split and divide and increase the number.
Synapse. If the excitatory synapse tells the motor.
No amount of jumping in the park like a yo-yo is going to increase these motor units or prevent any loss of them or whatever you're talking about. You're not going to lose them because they're post-mitotic. You don't lose them and you don't get more of them, just like fat cells. You don't get more fat cells and you don't gain more of them. They just blow up and they shrink. They get big and they get small.
Run, go. The inhibitory synapse tells it stop, slow down, hold back. Unlike the signal for excitatory synapse starting in the brain, inhibitory signals come from inside the spinal cord itself, from specialized inhibitory neurons.
Oh, yeah?
Simply put.
Here's a question. If a muscle were to hyperplasia, like they had these birds with these, weighted things on their fucking wings, would that if this thing would hyperplasia, would the motor neuron have to split too? And then it now occupies that new muscle fiber? Will you get a new motor neuron? I don't know. I've never looked it up in science. Maybe I should ask AI. I don't know. It's a possibility. See what I mean? Yeah. I don't know. Because that's where they reside. The motor unit resides in the muscle fibers. See, if you lose a muscle fiber, will you lose the motor unit? Yeah. Because they live there.
The brake pedal is local, built right into the circuitry. You can think of it like this. The brain sends the command to move, but the spinal cord has its own internal governing system that can cut, slow, or dampen the command before it even reaches the lower motor neuron.
Wow, okay.
And just like the excitatory synapse uses a microscopic bridge to deliver the fast go signal, the inhibitory synapse uses its own bridge, What crosses this bridge is completely different. Instead of VGLUT1,
Let's find out, man. Hold on. All right, so I asked AI a question about causing postmitotic muscle to split, some hyperplasia splitting. Would it innervate the existing new muscle fiber? Guess what it says? No. If new muscle fibers were formed through hyperplasia, they would be innervated by what? Branching from existing motor neurons, not by an entirely new motor unit. There you go. So yeah, I guess you're born with a certain set of motor units and they stay. So even if you were to cause this hyperplasia, if you had the ability to get it to split, it will just innervate. It won't have an entirely new motor unit, unfortunately. A motor unit is defined as a single motor neuron, and all the muscle fibers it innervates. New muscle fibers require innervation. Why is that? Because I guess the motor neurons, they reside in the spine. I don't know. They innervate muscles, but they reside in the spine, so they can only innervate. Okay, so that's where I got it wrong. I was thinking that they were living in the muscles. Sorry, they don't live in your muscles. They're in your spinal cord, whatever, your brain, your spine. So they innervate your muscles. So if you were to get this hyperplasia, it can only innervate muscles. That's all these motor units can do. This is what I was trying to talk about, branching. They will innervate them. That's all they'll do. Yeah, okay. Like it says here, rare. Controversial but rare hyperplasia in humans, yeah. It doesn't matter. It'll just innervate. So there you go. I didn't know. I had to look it up, okay, to make sure, because I didn't know. Now I know.
and VGLUT2 racing across the excitatory synapse like Lamborghini delivery vehicles,
Yeah.
the inhibitory synapse sends a signal with VGAT, vesicular GABA transporter, and VIAAT, vesicular inhibitory amino acid transporter vehicles. These are like slow, heavy UPS trucks.
Yeah, again, they only innervate. They only innervate from the spine. Sorry, going out to the extremities, they innervate. They innervate. That's what they do. It's important to have a healthy spine. I guess you should have a healthy spine. I've had spine problems for quite a while. I don't know. Still worry about it, but yeah, you definitely want to keep your spine as healthy as possible. That's why people don't really care for deadlifts, because they know they could destroy their spine doing deadlifts and even squats. You got to be careful. Yeah, once your spine is done, dude, you're gonna have a lot of weakness problems with this innervating your muscles from your spine. It could cause huge problems. You definitely don't want to end up like Ronnie Coleman or crippled walking around because you have a spinal cord problem and you're not able to innervate your muscles anymore, so they don't work anymore because there's no innervation. Yeah.
Lamborghinis across the bridge.
Lamborghini.
And inside these UPS trucks are the chemicals GABA and glycine. Your
GABA and glycine, yeah.
true brake transmitters.
Yeah.
These trucks move slowly and cautiously.
Oh, yeah.
They are not built for speed. They are built for suppression.
Sure.
And when these UPS trucks cross the inhibitory synapse
Yes.
and reach the lower motor neuron,
Yes.
they deliver one message: slow down, hold back, do not fire fast.
Yes, baby.
S'il te plaît, n'avez
Do not fire fast. This is the imbalance Castro found. Excitatory synapses disappear with age, inhibitory synapses remain strong. So what happens when the gas pedal weakens but the brake pedal gets stronger? Your system becomes dominated by stop, not go. The inhibitory synapse overwhelms the remaining excitatory input.
Oh, and then you age. And then you age. Is that it? You age. You're aging all the time. What are you talking about?
It pulls the lower motor neuron further away from firing fast. So even if the brain wants to move explosively, the spinal cord answers, I'm not letting that happen. And the result is the same every time. The fast motor units go dead
Okay.
because the inhibitory system won't let them fire. Now,
Oh, that's a bad thing.
Now that we understand what happens when the gas pedal gets cut and the motor unit goes offline, the next question is simple. What causes the excitatory synapse to be destroyed in the first place?
I know, it's a good question. What does?
That's exactly what I'm about to break down for you. Castro's study said that motor neurons initiate their own destruction during aging by activating microglia.
Oh, microglia, okay.
In a follow-up 2023 study, a few months after Castro's first study we discussed earlier, he talks about the microglia attacking synapses and motor neurons and possibly being the causal reason why we lose motor units as we age. But
well, that kind of sucks, doesn't it?
But he puts this in the very last sentence of his paper. Finally, it is plausible that microglia preferentially aggregate around motor neurons because of unique changes in firing patterns or excitability. Stick around because later I will show you that it is not plausible, but a fact that changes in firing rates and excitability are the reason why we begin to lose motor units. And microglia only attack after the synapses have weakened. Now, let's talk about this microglia and how it attacks these synapses in the first place. Let's break down the process step by step. In the second to last sentence of this study, Mr. Castro mentions CD200, but he does not explain what it is. So I'm going to help you out with this. Every fast excitatory synapse
why would he explain it?
has a protection shield sitting on it. It's called CD200. Think of CD200 as a neon sign that tells you microglia.
Yeah, CD200, yeah, okay.
This connection is healthy. Do not touch it. Microglia have a protein called CD200R on it. This is how CD200 on your synapse communicates to the microglia via the CD200/CD200R pathway. Do not touch me, I'm fine, hands off. When you're young and when you move fast, that CD200 shield is glowing bright. But as you age, especially when you stop moving fast, that shield gradually shatters. CD200 decreases. The synapse becomes unprotected. There is no CD200 to tell CD200R on the microglia not to attack. This is when the microglia starts circling and become prey. If CD200 stays high, there will be no microglia attack. The whole destruction chain never starts. Right now, science cannot increase CD200 in humans. The microglia do not automatically attack. There is an entire process that takes place. Let me show you how this happens. Step 1. Meet C1Q, the garbage tagger. Once CD200 is reduced or gone, the excitatory synapses begin signaling C1Q. What is C1Q? C1Q is a protein that's part of your complement system, a cleanup system of your body's immune system used to tag junk, dead cells, and weak connections so they can be removed. It is not the destroyer of the synapses per se, but it is the first recognition and binding factor that helps microglia identify targets to be destroyed and cleared. When C1Q is signaled, it looks at the quiet synapse and says, this one isn't doing its job. Mark it as garbage. It's like a soldier climbing onto the rock, the excitatory synapse, and driving a bright red flag into it. He's the one, C1Q, who marks it as the target. Step 2, the next player signal is C3b. What exactly is C3b? C3b is another complement protein. If C1Q is the first marker, C3b is the planted red flag that makes the synapse officially up for deletion. Once C1Q tags the weak synapse, C3b, the red flag, sends an eat me signal.
Oh, it does it? Oh, okay, yeah.
To the microglia. In step 3, the microglia
to the microglia, right.
Itself.
Sure.
As mentioned earlier, microglia are the brain and spinal
Of course, it's the brain and everything, yes.
cause immune cells.
Right, yeah.
Think of them like little Pac-Man cleaners.
Yeah.
They have a special receptor called complement receptor 3, CR3,
And what do? Do they eat them up and then they go away?
that recognizes and zooms in on the C3b's eat me signal the same way
They look like Pac-Man.
a submarine uses
Is that what they look like when you see them through like a scope or something, or what?
to zoom in on a target, locks the position, and once it's locked in, there's no escape.
Yes.
The microglia don't just swim towards it.
Don't you like that word synapses? I'm gonna start calling my channel Synapses now. That's my channel. It's gonna be called Synapses, Muscle Synapses, man. Motor Unit Synapses, bro. I gotta make a new channel, bro. Micro Synapses.
It launched like a torpedo, closing in on its mark, destroying the entire excitatory synapse like a speeding Pac-Man. The reason for this is that the motor neuron itself gave the microglia a superpower shot.
Oh, it did.
What do I mean by superpower shot?
How does he know all this stuff? Jesus.
It activated a protein called TREM1 protein, triggering receptor expressed on myeloid cell 1,
Oh, it has it?
which is found on the microglia itself. TREM1 acts like a superpower booster for microglia by amplifying their pro-inflammatory and pathogen-clearing functions. Once the microglia prunes that excitatory synapse, the motor neuron no longer receives the fast go signal for that motor unit.
Damn. That
Motor unit. Now that
that sucks.
you know how the microglia work, I want to jump ahead to another study. The one I mentioned earlier, he made a second study, Castro. And one of the lines stopped me dead in my tracks. Castro wrote, there is evidence that age microglia ablation, which means removal, reverses the age-related loss of motor units. Now that's a big...
It removes the age-related loss in motor units. It removes the age-related loss in motor units. So age-related loss. But it doesn't increase motor units because they're post-mitotic. Man, look, the question is this, man. I don't know what he's really getting at, but the motor units, you mean they're not working properly or something? It's because you got so much more deterioration and shit in your body. It's so deteriorated at this point. Your body can't regenerate fast enough to get rid of it. So yeah, this is the complications that you have. How do you know it's not microbiome issue? You know what I mean? How do you know that? Yeah.
Plain, because if that was true, we're talking about reversing one of the deepest parts of human aging. So I went straight to the evidence.
But the microbiome becomes dysfunctional too. So you could misconstrue a microbiome dysfunction as being a motor unit problem. See what I mean? Yeah. What's causing the microbiome to be dysfunctional? Peasant slave food diet. Yeah. It's kind of obvious. So what will trickle down to the motor unit being this so-called dysfunction or whatever, and not working properly? This age thing he's talking about, peasant slave food diet. So just get off it, and it'll all go away. Here's the thing: how do you cure all these problems? It's easy. Just go back on your natural food diet, bro.
Claimed, which was a 2019 mouse study by Elisa Giorgetti, and the moment I read it, one thing became obvious. She,
You
almost
see that? One small thing, you eating peasant slave food diet has created an industry of these people, like this guy, like influencers, doctors, scientists. It goes on and on and on forever. They need lawyers. They need this industry is just funded. Like they need scientists, they need biologists, like it's crazy. They employ people to pick these medicines, whatever, turn them into medicines. Oh man, it just goes on forever, bro. It's the insanity. The machines, the technology for it, oh bro. Never ends, man. Never ends. It's just endless. But guess what? If you stop doing that, it'll all go away because it's useless. It's useless. You're all pretending. So that isn't intelligent. To pretend, to create a problem and then pretend like you know something, you're sophisticated. Oh, it's this microglia and it's this and that and the motor units and you need to protect them by jumping around the yard and all that. You think that's high IQ? You think in your head that's high IQ. That isn't high IQ. That's not high IQ at all, and that's not intelligence. That's not you better look into, you could read, I guess you could read the dictionary, but you need to really reflect and think, What is really high IQ? What's intelligence? This isn't intelligence. But it may look to you as if, oh, these doctors, they went to school, they're intelligent, they're gonna help me. They're not gonna help you. They're not gonna do anything. They're there to make money off of you. You're a business. Is that intelligence? Well, you could say that's the game, or intelligent, if they're intelligent enough to steal your money. Yeah, if you're stupid. Look, here's the thing. If you're stupid enough to be duped by these people, then yeah, they'll take advantage of you. But if you're not stupid enough to be taken advantage of by them, then they can't exist. They're like leeches. They're like a leech. What do you do to leeches when they're stuck on you? You put salt. You put salt on them and get rid of them.
All the studies on this subject treated motor units like the primary cause of movement.
Yeah.
When in reality, motor units are the final common pathway to muscle contraction. Not the
They sure are.
beginning, not the middle, the last step. Which means this: you can fix a motor unit all you want, but if the entire
You can fix a motor unit all you want. It's like fixing your car, eh? Okay.
chain above it, the firing rates, the common drive, the descending drive, the initial signal is still old, damaged, and slow, and deteriorating.
See? Damaged, slow, old, deteriorate. There's that word. Deteriorating. That's what's happening. You need to outpace the deterioration. You need to regenerate faster than you're deteriorating. How do you do that? Like me, eat lots and lots and lots of animal products, and you will regenerate faster than you deteriorate. You understand me? And you have to do it over a long period of time. That's how we regenerate myofibers. We regenerate myofibers by putting ourselves in a regenerative phase where protein synthesis is outpacing protein breakdown. So it's the reserve in protein that's regenerating us.
Changed absolutely nothing
But it's got to be good protein and stuff, yeah.
about aging. So I dug deeper into this study.
Okay.
After seeing this claim,
Yeah.
I asked myself one simple question: how does she actually prove this? What measurement is she using to say motor unit losses were reversed?
Yeah.
Because if someone claims they reversed the loss of motor units, I expect to see one of two things: either they counted real motor units directly, or they use some kind of measurement that estimates how many are still functioning. So I looked at the methods, and here's what I found. She used young and old mice and used a test called MUNE, motor unit number estimation. Keyword, estimation. That means she did not go into the old mice and count motor units individually, one by one, under a microscope. Here's in simple terms how MUNE works. You have a nerve cell that carries the signal from the spinal cord to the muscle, and a muscle that contracts when the signal arrives. What she did was this. She stuck a recording electrode into the calf muscle of the mouse. Then she put a stimulating electrode near the sciatic nerve. That's the big nerve going down the leg.
Oh, yeah.
Instead of letting the brain and spinal cord send the signal, she zapped the sciatic nerve with electricity from the outside with the
Damn.
stimulating electrode.
Zapped.
That shock forced some motor axons to fire. That's the wire I mentioned that transmits the signal to the muscle. And the muscle twitched. The electrode in the calf muscle recorded the electrical response.
See, electrical response. What did I say previously? And then it twitched from the electrical response. It twitched, yeah. We have electricity in our bodies.
That big response from the muscle is called CMAP, the compound muscle action potential. Think of it as how big the total electrical input of all motor units were activated. Then she slowly increased the shock in tiny steps. Each step is
Without electricity, we'd be dead.
supposed to recruit one more motor unit. Those little jumps in the signal are called SMUPs, single motor unit potentials. Then she did one simple division. MUNE equals CMAP divided by the average SMUP. That's it. That's how she estimated how many motor units were still functional. So remember this, she never counted real motor units directly.
That's incredible.
She used an electrical trick at the very
She counted these motor units. Oh, they're counting them. Okay. You can count them?
end of the system. She stimulated the axon with an unofficial shock and measured the muscle's reaction. In other words, she played the role of the neuron from the outside. A neuron is just a transfer station. It receives the movement signal from the brain and passes it down its axon, the electrical wire, to the muscle fibers. Simply put, she bypassed
Yes, of course it does. Yes.
transfer station.
Yes.
Now, what does Georgetti
Transfer station.
claim? She used two interventions on the old mice: voluntary exercise, wheel running for 2 months,
Oh, she did she? Okay.
and then she used a drug that wipes out microglia, a CSF1R inhibitor called BLZ945.
Oh,
Let
she
me
did.
break these down for you. The exercise part first. She took aged mice around 21 months old, which is old for a mouse. First, she measured the MUNE, the estimate of how many motor units were still working. Then she put them in cages with a running wheel for 2 months. They could run as much as they wanted. After those 2 months, she measured MUNE again. So what did she see? Before the exercise, MUNE is low, fewer functional motor units. After 2 months of running, MUNE goes up,
Yeah.
back into the range of youthful adult mice.
There you go.
From that, she writes that exercise restored the number of functional motor units. That's the first proof that she supposedly reversed the loss of motor units.
Incredible.
Now let's talk about the second method,
It's incredible.
the drug and the microglia. According to Georgetti, something changes with age. All the microglia are the cause of loss of motor units with age. This is what she says. That's her story.
You know, I had these old people. I knew them. They lived in the old neighborhood. It was an old couple, and they would grow like stuff in their backyard, and they would grow beets. They would grow beets. You know, beets, and they would juice these beets and drink them like crazy. These fucking beets and shit. They thought that that was the thing to longevity, being healthy and everything. If anything, it degenerated them drinking it. It did the opposite. The husband was getting worse, practically crippled. She was completely like deteriorated, falling apart. They were doing the opposite. Instead to eat meat, especially in its raw state, or blend some liver, they could blend liver with something and drink it every day. That would have made them so much better every single day. Just a little bit of liver even. That's like a super multivitamin. They would have been amazing, man. You know that? They would have been amazing. Plus eating just meat, and they forgo eating any kind of plants and slave food diets and carbohydrates and shit, which was deteriorating them even faster because it starts accelerating on itself. At this point, you're so deteriorated, your progenitor cells, you're suffering from something called myogenic decline in senescent cells. So now the acceleration is going, it's like on high speed, high octane, boom. You know what I mean? Because now it's just, there's less of them for repair. You're destroying them on peasant slave food diet at the same time. They just can't keep up, bro. You have to give them an environment so they're able to repair you. They're able to expand their pool. They could go back to quiescence, expanding that pool for further regenerative demands. You have to furnish that ground for them to thrive. But if you don't, and you keep destroying them, and you're destroying yourself, you're defeating the purpose. Get it? Just like this old coot. He's defeating the purpose of regeneration. None of this, what he's talking about here matters.
Her solution? Let's remove them and see what happens. And this is where she
Look, if I stand next to him, man, I mog this guy. We're almost the same age. I mog him. I destroy him. Yeah.
uses a drug called BLZ945.
Think about it. Who do you think's going to be better when they reach 70? Him or me? When I reach 70, he reaches 70. Who do you think is going to stay static and still look as young as they did, youthful, like in their 30s or whatever? Who do you think is going to look like that? Him or me? See, I'm just eating like raw animal products, and I'm eating a lot of them because I'm outpacing this breakdown constantly. I'm trying to keep it for as long as I can. Now I do take breaks, but then I go back on it again. See what I mean? I keep a positive nitrogen balance so that I'm anabolic, so that I'm repairing faster than I'm degenerating. That's the idea. Do you think he does any of that? No, that's why he's degenerated. See what I mean? He's going to explain to you that, no, exercise got magic powers. It's going to preserve these motor units, and you're going to live forever. No, you're not. See what I mean? Food has power on this fucking planet. Exercise has no power. What's exercise? Nothing. Nothing. Food has power. Food.
BLZ945 is a CSF1R inhibitor. CSF1R is a receptor that microglia need to survive. If you block it long enough, microglia die off. So she takes the old mice and puts BLZ945 in their food for about 2 months. In some of the mice, it's continuous treatment. In others, it's 1 week on, 2 weeks off, intermittent schedule. In both, the result was the same. Microglia was wiped out. So how does she test what happened? Back to MUNE. Just like before, she stimulates the sciatic nerve with electricity. What happens to the mune after the drug? In all mice without the drug, MUNE was low. After 2 months on BLZ945, the MUNE number in those old mice.
See what I mean? Does any of this matter? No. Why do people hate my channel? Why are they jealous of me? Because I have people writing me now sometimes in the comment section. They're disgruntled, man. They got to tell me bad things all the time. You know, some majority of people write nice comments or certain comments, things that I do, because they just make reaction videos. But I got people trying to hit me and stuff. Why? Because I'm honest. You know, it's better to be dishonest as that dishonesty pays in this world, right? So if I'm a dishonest and I feed you what you want to hear, your fake beliefs, is that better for you? Yes, lift heavy weight. It builds muscles. Weights build muscles. Muscles, they grow when you walk with a bull and all that. Yeah, sure they do. Doing all these exercises, you're going to preserve these motor units. You're going to keep them forever. You're going to live to 150. Yeah, like Tony here. Yeah, of course. Well, is that what you want to hear? Have I confirmed your fake beliefs? See what I mean? So you don't want to hear that food and money builds your bodies. Food. If you're poor, I guess it doesn't work for any of you. See what I mean? Why do you think rich people are so highly revered in this world? Why do there? I could show you rich people. Why they eat? Rich eat, and the poor work. I've said this over and over again. Why do the rich eat and the poor work? Because the rich don't work. They eat. Get it? Now, are they eating the right foods? I don't know. You know what I mean? They're obviously brought up like everybody else. They're all of them in the same thing. But they can't eat raw animal products and regenerate and look good if they want to. It depends on how bad you want it. The question is this: how bad do you want something? And if you want it bad enough, you'll go after it. But if you don't want it bad enough, you won't go after it. You won't give a shit. You have to want it bad enough. There's a difference.
Back up.
And don't do it because other people pressured you into doing it. Do it because you want to do it. But if you do it for other people, you'll never be happy.
To the youthful adult range, reversing the age-related loss of motor units. So what exactly is the flaw here? Is there a flaw?
Reverse the age of motor units, whatever the aging of them. You want to know how to do it? I already told you. Money will reverse your aging. And eating raw animal natural products. That's what does it. Being in positive nitrogen balance. You being able to regenerate faster than you degenerate. That's how you do it. Okay? Science tells you that.
It's simple. Everything she measures is at the very last step of the system, using artificial shock in a muscle that still has to.
And no, I don't need science to tell me that because I've seen it. You can see it on people when they eat natural food. They don't look as deteriorated as these other slaves. And there's nobody on a complete natural diet. There are people now going on a completely natural diet, yeah. But you notice the difference. The looks maxing community shows you how they look so amazingly youthful.
Surviving, compensating motor units. She never showed how fast the mice ran before and after, how strong they were before and after, whether their movement patterns looked like young mice. She only showed when I killed the microglia and then shot the nerve, the number my machine spits out, MUNE, went up. That's not reversing the loss of motor units. That is unblocking and optimizing survivors. And that's the difference. And the next flaw is simple. As I mentioned earlier, the motor unit is the final common pathway to muscle contraction. This researcher is trying to fix the last part of the movement.
Of course it's part of muscle contraction, but so is muscle, so is a bunch of things. Muscle fibers and a bunch of things, yeah.
which makes absolutely no sense. Let me break it down with an example so you can understand it better. Your house lights go out. Her reasoning is if I replace the light bulb, the whole system gets fixed. But the light bulb is just the final common pathway of an entire electrical network. The power plant, the transmission lines, the transformers, circuit breakers, house wiring, switches,
Yeah, sure.
connectors, the bulb socket, and finally, the bulb itself. If anything upstream
Of course.
fails, the bulb goes dark. But the bulb was never the problem. This study believes that removing the microglia that are attacking the synapses that are connected to the motor neurons will fix the problem, bring back, and even reverse the loss of motor units. Even if you magically restore motor units or increase CD200, an older person will still move their age, not younger by any means. Let me show you why fixing motor units and removing microglia means absolutely nothing. Because the part that dies first isn't the motor unit, it's the signals that come from the brain. When I say signals from the brain, I'm not talking about one simple one. I'm talking about a three-part command system that hits your motor neurons before your muscles even contract. And here's the key.
Yeah, of course, yeah.
Your motor neurons do not decide anything on their own. It's
Yeah.
like a power outlet. It only does...
Okay, I'm going to speed this up because he's just going to waste time here because the video is going way too long already. Oh my God, 1 hour. This is nuts, dude.
What the incoming signals allow it to do. The goal command signals to a motor neuron come through fast synaptic signals called ionotropic inputs from the cortical spinal tract, the reticular spinal tract, and sensory pathways. These hit the motor neuron in milliseconds and instantly push it towards firing or instantly shutting down. Let's break them down. The first one is called the cortical spinal signal pathway. This is a voluntary command line. The decision to move starts in your motor cortex, the part of your brain that says move now, and it runs down the spinal cord where it hits the motor neuron. In simple terms, this is your top-down launch signal. You do it on purpose commands. Cortical spinal signal uses VGLUT1 because it helps carry the go signal from the brain to the muscles. When you move, your brain sends a message to the spinal cord. This message is carried by VGLUT1
Oh, brother, man, I can't listen to this anymore. This is just ridiculous, bro.
to the motor neuron so it can be sent and strength. Third is the sensory signal pathway. Now follow the diagram. This signal does not start in the brain. This one starts in the muscle fibers.
Okay.
Look right here on the left side there. See the bright point inside the muscle?
Yeah, I see it.
Twist or fall. From there, the signal runs down the motor axis. Just happens. That's why this cord. And what do? They help create what's called PICs, persistent inward currents.
Yeah, they sure
By the
do.
way, these systems must work together.
Of course they do, yeah.
Don't fail all at once. They fade quietly,
Okay.
but actually makes you old. When Lexel, a motor unit expert from the past, said decades ago that motor unit loss is neurogenic,
It's neurogenic. What did it say there? Man, hold on a second.
fast, you tell yourself, I'm just as fast as I was when I was 20. Maybe you are.
I am. I am now much more because I'm not mitochondrial dysfunction, not eating carbs.
That is after the movement gets going, but not at the start, not in the instant, and definitely not in the burst. That
Oh, I'm fast at the burst at the start.
part is already slipping, and you don't even notice it. And it
No, it's not slipping at all, actually. God, it's so much better.
affects your entire neuromuscular system. This is the one that
Anything at my spine, if it's unhealthy or something bad there that I have, yeah, definitely would affect it.
increases with age under 0.50 milliseconds explosive movement. And this right here is what actually makes you old. When Lexel, a
Oh, that's what actually makes you old. So it's not the loss of, it's not myogenic decline and senescent cells and you taking on more damage than you can repair. No, this is the process of aging, yes. Yeah, but I always thought aging was a number, measure of time, but that's aging? Okay. You don't think it's like, what is he trying to do? He's trying to figure out what aging is, like time? Okay, whatever. Human aging, muscle mass, and fiber type composition. Yeah, human aging, muscle mass. Yeah, aging. What is aging?
motor unit expert from the past said decades ago that motor unit loss is neurogenic. That's what he meant. Not
Motor unit loss is neurogenic. Yeah, neurogenic, yeah.
cells.
disease, whatever.
not genes, not molecules. This has nothing to do with the so-called hormone.
See, sarcopenia, is that the loss of muscle fibers? No. Sarcopenia is the loss of muscle mass. Why are you losing muscle mass? Because you're suffering from myogenic decline, a loss of stem cells. Do you understand me? If you're suffering from sarcopenia or anything, sarco-osteopenia, it's because you're suffering from a loss of myogenic decline. So the question is this: how do you increase the stem cell pool? By regenerating it periodically. You do an exercise that you're unaccustomed to do. You go in, you're accustomed to doing it, and it will activate the progenitor cells. Well, some people will call that hormetric. See what I mean? So there's no benefits exercising yourself. Now you know that muscles are postmitotic. You know that these motor units are postmitotic. So why are you chronically exercising yourself in a gym when it's not regenerative? What's regenerative? Periodic exercise is regenerative because you're unaccustomed to it. So it's regenerative and it'll expand the stem cell pool. So you won't run into any of these problems. See what I mean? Yeah. Get it, dude?
Of aging. Stem cells can't fix this. Gene therapy
Stem cells can fix that. That's why they say there's a reserve in stem cell pool for further regenerative demands.
cannot fix this. No drug can.
No, drugs can't fix it because only food can fix it. Food has power to fix that. And I just told you, these periodic bouts of exercise will activate the stem cells to expand that stem cell pool. Now, wait a second. You can do it. People will say you'll increase these stem cells if you fast and then you overeat. So fast and overeat. But here's the thing. Will the stem cell pool go away if you're in positive nitrogen balance? No, I doubt it ever. It will not go away. So we'll definitely maintain them. They won't go away. See what I mean? Yeah. So food does have a lot of power when it comes to stem cells. They can create because of food. They can't create themselves if there's no food and a bunch of stuff.
We built this because this isn't a part, it's a timing system. So you must train this RFD continuously and with plyometrics, speed, change of direction,
Oh, yeah.
and proprioception drills. However,
Yeah, change of direction. See, exactly what I'm saying. I'm saying unaccustomed, untrained, unfamiliar forms is what gets this damage, what activates what the stem cells to expand the stem cell pool. But he says proprioception. He wants you to be adapted and doing things like moving angles, proprioception. In other words, so you go in this direction and then you go in that direction, get it? And that will magically fix you. But everything he's doing is the opposite. He doesn't focus on being in positive nitrogen balance, on eating food, especially real food. He doesn't eat that. He eats sludge, peasant slave food diets. It's all garbage. And he's a chronic exerciser. Doesn't matter how much proprioception you do. That's great. That's great for football. But that doesn't work in the natural world to regenerate you. Even animals, when they're sedentary, when they get up and run, whether they're being pursued or pursuing for food, they go through this damage and then they go through a regeneration. Yeah, they get damaged because they're accustomed, dude. Get it? So yeah, even they go through it as well, and they eat their natural food.
this would only help in sports. There are two other things that need to be done to slow the loss of these three signal pathways, and this takes me to the next requirement when you apply to longevity. The next one is repetition. This is where most, if not all, get it
Gravitation, like gravitational pull.
wrong. They say martial arts, it's everything. Overcoming isometrics, fix this and that. Jump rope, yoga, tai chi, sprinting, and on and on.
Yeah, sure.
Nervous system does not care what you do. It cares whether it still needs to solve the problem, a problem. When you repeat the same movements,
Yeah, it can't solve the problem without material. It's like trying to build a house without any workers. The workers are these in muscles, they're nuclei, and what's the material? The food. There has to be reserve in protein. No reserve, no repair, no nothing. Or yeah, they may just take whatever's there and just repair it. It won't expand the stem cell pool. There'll be no remodeling, a bunch of stuff, okay?
Same speeds, same angles, same timing, same patterns. Your nervous system adapts and automates them, and the firepower from the three signals, the ionotropic inputs, decline. The excitatory synapses I mentioned earlier in the video send the signals, but the inhibitory ones
They decline, yeah, okay.
counteract them. Even though you think you're moving fast, as in martial arts kata, your body's so used to the movements that internally the nervous system interprets them as being slow. In plain terms, the signal gets quieter because they are no longer needed at full volume. Nothing has changed, so your body gets used to the movements. You think you're still
Yeah, your body gets used to the movements. Nothing changes. Get it? It's no longer regenerative. You're adapted to your exercises. There's no more micro damages.
fast. You're not. You're just efficient. And efficiency is the enemy of explosiveness. This is why people
Yeah, efficiency is the enemy of explosiveness. Why is that? Because it's not hormetric. It's not regenerative. That's why. You want to do things you're unaccustomed to doing. That's why. So you can get more of these, a donation of these nuclei. They enhance your performance.
plateau,
They're the fixers of your body. They fix you.
even while training hard. You must challenge yourself to continuously change your movements to keep your brain and motor units.
See, he agrees with me. You need to change your movements. In other words, you need to do a lot of exercises that you're unaccustomed to doing. Get it? So that you can regenerate. He just says it in a different way. He thinks it's about, these angles and things in exercise. It kind of is. But what he does isn't based on muscle regeneration, though. Get it? He's not focused on getting these micro damages to activate the satellite cell, to expand the satellite cell pool. Now, he's kind of saying stuff because he probably watched my videos. He's kind of mentioning this because I guess he doesn't want to let it slip.
Guessing at your unpredictability.
Yeah, you keep it guessing at your unpredictability. You don't keep it guessing. You do things that you're unaccustomed, unfamiliar, untrained. Eccentric exercise is what caused that damage, and it'll expand the satellite cell pool. They'll come out, they'll proliferate, differentiate, and then they'll go back into quiescence. Okay, they'll split, divide, increase in number, expand the satellite cell pool.
That means new speeds, new timing, new coordination demands, new threat levels,
New muscle cells, new everything. Yeah. Collagen remodeling, yes. Gonna get stronger, better, faster. Bigger, better, stronger, and faster. EIMD training, exercise-induced muscle damage, is associated with strength, power, speed, and performance.
problems to solve. If the brain knows the answer, it stops asking questions. And when the brain stops asking questions, the three pathway signals plateau, fade, and become dull. And this is when your entire nervous system begins to slip quietly. Now, here's the third principle that you need to do to slow down the loss of motor units in aging. It's called chaos training. Let me start with the definition of the...
Again, with the chaos training, you're adapted. There's nothing happening in chaos training. It won't happen. It's not going to do very much.
word chaos. The actual definition of chaos is complete disorder and confusion. Not even the best coaches in the world apply it correctly. Let me explain.
So would this be considered chaos in weightlifting when you're doing things that you're extreme exercise, unaccustomed, unfamiliar, untrained? See what I mean?
People always tell me, you don't know what you're talking about. Martial arts is chaotic. Tennis is chaotic. Football is chaotic. No, they're not. And this
They are chaotic. They are chaotic. They are. Yeah.
This is where people get fooled. Martial arts look chaotic, tennis looks chaotic, sports look unpredictable, but to the nervous system, they're not. There's no complete disorder or confusion. Why? Because there are rules, there are lines, there are boundaries, there are visual cues. Chaos disappears the moment the nervous system starts recognizing structure. When a tennis player serves the ball, your nervous system sees the body position, the shoulder rotation, the arm path, the toss, before the ball even leaves the racket. That's not
So what? They're there to just play tennis.
chaos, that's prediction. It doesn't matter if the ball bounces slightly different. Your nervous system already prepares the response before it happened. This is not definition of complete disorder. And here's the truth people do not like.
That's why I tell you, you can use gyms as a regenerative bout. That's all. It's really simple. Yeah.
If your nervous system can see it coming, it will slow the signal down. That's how it saves energy. That's how it becomes efficient. And efficiency is the enemy of speed. I said it earlier.
we know
Martial
that.
arts aren't chaos either.
Yes, we know that.
Even in martial arts, the distance is known, the stance is known, the timing is trained, the movements repeat. Your nervous system learns, well, I've seen this before. So it starts reacting fast. It starts anticipating instead of responding. That feels skilled. That feels smooth, but it's also slower. Sports train patterns, and patterns train predictions, not complete disorder and confusion. Prediction kills urgency. Urgency is speed. Real chaos is not reactive to something outside you. Real chaos means your nervous system does not know what's coming next. There are no visual cue warnings, no preload response, no patterns to lean on. The decision happens so late that the brakes can't engage. That's when fast signals stay alive. Engage. That's when fast signals stay alive. To keep your motor units alive, you must do the unexpected. You must instantly deviate, change movements on the fly, in a way you've never done that in a specific order. Only this keeps neural signals strong, fast, and responsive. This is the line people must understand. The nervous system doesn't slow down because you get weak. It slows down because it gets comfortable. Sports make it comfortable. Repetition makes it comfortable. Skill
Yeah, you're all comfortable, even in the gym. It's a problem.
makes it comfortable.
Yeah.
Comfort is the beginning of decline. So let me leave you with this. Researchers are not claiming they
Comfort is not the thing of decline. Again, it's your peasant slave food diet that's causing you to decline. See what I mean? Yeah.
can reverse the loss of motor units. They're not even close. Not
You're laboring and weird exercise and things you're doing, they're all contributing.
close at all. And the reason is simple. They are trying to fix the final step of the system while completely ignoring everything above it. I showed you what actually breaks with age. I showed you where movement really comes from. And I showed you why these signals cannot be reconstructed once they're gone. This isn't biology you reset. This is a timing system. Once those signals fade, no drug, no gene therapy, no stem cells, no biomarker panel brings them back. What can be done is protect what you still have. And here's the most important part. You're not too late. Even at 60, even at 70. Even if all you can do is train once a week for 10 to 15 minutes, you must protect what remains. Because once motor units
Yes, okay.
are gone, they are gone forever. And no biological
Yeah, no kidding, okay.
age test will change that. I'm not promising you 150 years. I definitely ain't promising you immortality. Nobody can.
But they'll innervate, so yeah.
What I am saying is this. We do not know what happens if a human being keeps their nervous system young for as long as possible because it has never been done before. 20-year-olds have all three signal system intact, and they don't have chronic diseases unless they have genetic defects. So what happens if you keep the system alive longer? No one knows. And that question alone is worth fighting for. I've given you the principles here. I've shown
He has.
you the logic. I've shown you the limits. This channel isn't about fantasy. It's about reality.
Yeah, so if you do chaos training, that's going to preserve you. It's going to wear off fucking aging or deteriorating and all this stuff. Sure it is, yeah. It's got magic powers, dude, yeah.
And reality
Chaos training, yes, dudes. So go out there and do your chaos training and tell me how it works for you in the next 20 years.
says this.
So listen to me. I'm gonna stick to my periodic lifting, which is regenerative because it's a known fact. PubMed, satellite cell aging, use it or lose it, tells you periodically. You remove myogenic decline in senescent cells doing that. You get an influx of these new cells. There's a remodeling, and I'm going to stay in positive nitrogen balance. And I'm going to eat a natural diet, raw animal products, and stay in a positive nitrogen balance. See what I mean? So who do you think is going to have more chances of being static and being more functional over time? Him or me? Him doing his chaos training and me eating natural food. Him eating peasant slave food diet, deteriorating, doing exercise, which exhausts the stem cell pool. This chaotic exercise is exhausting the stem cell pool. That's why he looks so degenerated. I don't. See the difference?
You are your age, not a number on a test, not a score you can gain. Time is time.
Yeah.
The only question is how well you move inside that time.
Look how old he looks. And then we're going to say old. Look how degenerated he looks. This is a sign. I told you before, a lot of people don't look at the signs. When you have gray hair or loss of hair, gray hair, you're losing hair, this is a very bad sign. You understand me? That's an exhaustion of some stem cell. Now, your kidneys use something called myocytes, but they're also shared by your hair follicles. But if they're so busy trying to fix your kidneys, it's like a reserve. They have to go there to keep regenerating your kidneys because they're under attack from peasant slave food diet and oxalates and whatever else. And so that's why you exhaust them. And so they just simply leave that area and they just say, we don't need to be here anymore. And they just stay there in the kidneys. and you've exhausted them in the upper part of your body. That's why they're not working anymore. Your hair turns gray, the follicle, whatever. Yeah. I mean, depending on the damage to the kidneys, it depends. I don't know. It really depends there. But it is a type of stem cell exhaustion. You don't want to exhaust any stem cells in your body. But you can see here, he's suffering from stem cell exhaustion. This is a sign of stem cell exhaustion. When you look at him, take a good look at Tony. Stem cell exhaustion. Do you want that? Is that something that you want? Have you ever seen dogs that are malnourished when they don't eat and they're in the street? You see what happens to them? They start losing their fur, right? They're malnourished. That's peasant slave food diet. So he's suffering from malnourishment. That's number one. He's suffering from malnourishment, that's for sure. And he's suffering from a myogenic decline. And they kind of go hand in hand, really, you know. The myogenic decline, the malnourishment. Why the malnourishment? Because on peasant slave food diet. Yeah, it's kind of obvious. So then this accelerated deterioration starts flying off the handle with every decade. You understand me? Because at this point, it's exhausted. Yeah. So you want to expand the satellite, you want to expand the stem cell pool, right? And you want to stay in positive nitrogen balance, meaning that you want to eat natural food so you're nourished, not malnourished. There you go.
That's what this channel is about. That's what I'm doing. I see you next time.
Sure. I'll see you in the next time too, friends. Tony from I Am Longevity. He's going to save your life, bro. He's going to save you by doing chaos training, bro. Yep. And eating peasant slave food diet. See you in the next one. Ciao, friends.